The SR489 Generator Management Relay is a microprocessor-based relay designed for the protection and management of generators. It is equipped with 6 output relays for trips, alarms, and control. 9 digital inputs may be configured for different functions, such as remote opening and closing of the breaker, reset, or alarm with a programmable name, to name a few. 2 of the 9 inputs are dedicated for breaker status and set point access protection. The 489 includes current, voltage, and power protection elements, including overcurrent, differential, and overpower elements. In addition to the 13 standard ANSI, IEC, and IAC inverse curves, the 489 offers a custom flex curve that can be specifically designed for custom overcurrent protection. Generator protection, fault diagnostics, power metering, and RTU functions are integrated into one economical drawout package. LED indicators for the 489, generator, and output relay status, in addition to a 40-character message display and keypad, allow control, programming, and status monitoring without the need for a computer. However, the conveniently located front RS-232 port allows easy connection to a computer for programming and monitoring. The relay's drawout handle has provision for a wire lead seal to detect unauthorized removal. The relay is packaged in the standard Multilin SR series configuration of a drawout unit and companion fixed case. The case provides both mechanical protection and is the termination for all connections to external equipment. Current transformer connections within the case are fitted with automatic CT shorting mechanisms. The unit is held in the case by pins on the locking handle, which cannot be fully lowered to the locked position until all electrical connections are fully mated. Any SR489 can be installed in any SR489 case. An index pin keying mechanism prevents relays other than the SR489 being inserted into the case. Relay display. All messages are displayed on a 40-character liquid crystal display to make them visible under poor lighting conditions. While the keypad and display are not being used, the display will default to user-defined status messages. Any trip or alarm will automatically override the default messages and appear on the display. Pressing the Help key for 2 seconds will initiate a lamp test. There are 2 different displays available for the SR489 relay. These are the Enhanced and Basic. New production units will be enhanced, while older relays already installed may have the Basic display. The main difference between the Basic and Enhanced display is a larger LCD display and the keypad interface. The Basic display uses separate set point and actual keys to enter the main headings. The actual key is used to navigate through the headers of pages of measured parameters, while the set point key is used to navigate through the headers of pages of programmable parameters. The actual key will enter a different actual value heading each time it is pressed. Once you have entered the actual value heading you want to view, the message up and down keys may be used to navigate through the subgroups. The functionality of the remaining keys remains the same as the enhanced display. The SR489 has 3 groups of LED indicators on the faceplate that indicate the status of the SR489, generator, and output relays. First, let's look at the SR489 status LED indicators. The Relay in Service LED indicates that control power is applied and all monitored input, output, and internal systems are OK, and the relay has been programmed and is in protection mode, not simulation mode. When in simulation or testing mode, the LED indicator will flash. The Set Point Access LED indicates that access jumper is installed and passcode protection has been satisfied. Set points may be altered and stored. The computer RS-232 LED flashes when there is activity on the COM port and remains on continuously if incoming data is valid. The computer RS-485 LED flashes when there is activity on the COM port and remains on if incoming data is valid and intended for the slave address programmed in the relay. The auxiliary RS-485 LED flashes when there is activity on the COM port and remains on continuously if incoming data is valid and intended for the slave address programmed in the relay. The Alt Set Points LED will turn on if the alternate set point group is active and being used to protect the system. The Reset Possible LED indicates that a trip or latched alarm may be reset. Pressing the Reset key will clear the trip or alarm. The Message LED flashes when a trip or alarm occurs. Pressing the message down key will scroll through diagnostic messages. Generator status LED indicators. The breaker open and breaker closed LEDs will indicate the status of the breaker based on the condition of the breaker status digital input. The hot stator LED indicates that one of the stator RTD alarms, trips, or thermal capacity elements has picked up. The negative sequence LED indicates that the negative sequence current alarm or trip has picked up. The ground LED indicates that at least one of the ground overcurrent, neutral overvoltage, or neutral undervoltage elements has picked up. The loss of field LED indicates that one of the reactive power elements has picked up. The VT failure LED will illuminate when the relay VT fuse failure alarm has picked up. The breaker failure LED indicates that the breaker failure or trip coil monitor alarm is picked up. Output relay LED indicators. The R1 trip LED indicates that one of the relay protection elements has issued a trip and the trip contact has energized. The R2 auxiliary through to R4 auxiliary LEDs indicate that an auxiliary output contact has operated or energized. These output contacts are assigned under the individual protection and monitoring elements. The R5 alarm LED indicates that one of the relay elements has issued an alarm and the alarm contact has energized. The R6 service LED indicates that the R6 service relay has operated due to the detection on an internal relay failure. The relay's messages are organized into pages under the main headings of set points, actual values, and target messages. The menu key is used to navigate through the main headings. Each page is broken down further into logical subgroups of messages. The message key may be used to navigate through the subgroups. For example, when the menu key has been used to select the actual value main page, pressing the message right key will move you into the A1 status menu. The message up and message down buttons can then be used to view the headers for the other actual value submenus, such as A2 metering data and A3 learned data. To view the specific information in a subheading, use the message right key. For example, when in the A1 status subheading, press message right to see the heading for generator status. The message up and down keys can again be used to navigate the headings under the A1 status subheading. The Enter key has a dual purpose. It is used to either enter the subgroups or store altered set point values. The Escape key is also dual purpose. It may be used to exit the subgroups, or it can be pressed to return an altered set point to its original value before it has been stored. The Value Up and Down key is used to scroll through variables in the set point programming mode. It will increment and decrement numerical set point values. Alternatively, these values may be entered with the numeric keypad. The Help key may be pressed at any time for context-sensitive help messages. The Relay Front RS-232 port. This port is intended for connection to a portable PC. Setpoint files may be created at any location and downloaded through this port using the EnerVista setup program. Local interrogation of set points and actual values is also possible. New firmware may be downloaded to the relay flash memory through this port. Upgrading of the relay firmware does not require a hardware EPROM change. Relay installation. The relay case can be installed in the panel of a standard 19-inch rack, either alone or adjacent to another SR series unit. Make sure that the front door of the relay is able to swing open without interfering with adjacent equipment. Normally, the relay is shipped in its case from the factory. The relay should be removed from its case before mounting the case in the supporting panel. To remove the unit from the case, first, turn off control power before drawing out or reinserting the unit to avoid maloperation. To remove the unit from the case, open the cover by grasping the center of the right side. Press upward on the latch and then pull the front door, which will rotate about the hinges on the left. Release the locking latch located below the locking handle by pressing upward on the latch with the tip of a screwdriver. While holding the latch raised, grasp the locking handle in the center and pull firmly, rotating the handle up from the bottom of the unit until movement ceases. Rotate the handle to the stop position. Once the handle is released from the locking mechanism, the unit can freely slide out of the case when pulled by the handle. It may sometimes be necessary to adjust the handle position slightly to free the unit. Mounting instruction. Review the dimensions and location of the relay wiring before selecting a location within the panel that is appropriate for the relay. Cut the hole in the panel to the dimensions shown in the drawings. After the mounting hole in the panel has been prepared, slide the relay case into the panel from the front. Apply firm pressure on the front to ensure the front bezel fits snugly against the front of the panel. Bend out the pair of retaining tabs to a horizontal position from each side of the case. The case is now securely mounted and ready for panel wiring. If additional support is desired, the optional SR mounting kit may be ordered. Inserting the unit into the case. If an attempt is made to install a unit into a non-matching case, the mechanical key will prevent full insertion of the unit. Do not apply strong force in the following step, or damage may result. Raise the locking handle to the highest position. Hold the unit in front of the case and align the rolling guide pins near the hinges of the locking handle with the guide slots on either side of the case. Slide the unit into the case until the guide pins on the unit have engaged the guide slots on either side of the case. Grasp the locking handle in the center and press down firmly, rotating the handle from the raised position towards the bottom of the unit. When the unit is fully inserted, the latch will be heard to click, locking the handle in the final position. Digital inputs. There are 9 digital inputs that are designed for dry contact connection to other devices. 2 of the 9 digital inputs have been pre-assigned as breaker status and access and have their own common terminals. The breaker status input may be configured for either a 52A or 52B auxiliary contact. This will let the relay know if the breaker is open or closed. The access switch input must be shorted to allow settings to be configured using the front keypad. This is commonly wired to a key switch on the front of the switchgear, allowing only authorized personnel to change settings. The remaining 7 digital inputs all share a common terminal and can be assigned to any of the protection or monitoring elements of the relay. Shorting any of these input terminals to the D23 common terminal will assert the input. There is also a 24-volt DC switch supply provided. This will provide control power for inductive or capacitive proximity switches. The NPN output of the proximity switch can be connected to any of the 4 assignable digital inputs configured as a counter or tachometer. The maximum allowable current draw for the plus 24-volt DC switch supply is 20 milliamps. The control power supplied to the relay must match the installed switching power supply. If the applied voltage does not match, damage to the unit may occur. The order code on the terminal label on the side of the drawout unit specifies the nominal control voltage as one of the following. For low voltage connection, the label will read low 20 to 60 VDC, 20 to 48 VAC. For high voltage connection, the label will read high 90 to 300 VDC and 70 to 265 VAC. Extensive filtering and transient protection are built into the relay to ensure proper operation in harsh industrial environments. Transient energy must be conducted back to the source through the filter ground terminal. A separate safety ground terminal is provided for high-pot testing. All grounds must be hooked up for normal operation regardless of control power supply type. The SR489 has 3 channels for phase current inputs, each with an isolating transformer. There are no internal ground connections on the current inputs. The phase CTs should be chosen such that the full load current is no less than 50% of the rated phase CT primary. Ideally, the phase CT primary rating should be chosen such that the FLA is 100% of the phase CT primary or slightly less, never more. This will ensure maximum accuracy for the current measurements. The maximum phase CT primary current is 50,000 amps. The relay will measure correctly up to 20 times the phase current nominal rating. Since the conversion range is large, 1 amp or 5 amp CT secondaries must be specified at the time of order such that the appropriate interposing CT may be installed in the unit. CTs chosen must be capable of driving the relay phase CT burden. In addition to the 3-phase current transformers, the 489 provides input for 3 additional CTs called the neutral end CTs. The primary purpose of these CTs is providing the current amplitude and phase angle measurements that will be used in conjunction with the phase CTs for differential protection. The neutral end CTs are wired in a similar fashion to the phase CTs, only on the neutral leads of the transformer. Because the phase angle of the metered current is critical to the phase differential protection, it is important that the neutral end CTs are wired with the correct polarity. The neutral CT secondary currents must be injected to the 489 relay so that their phase angle is offset by 180 degrees when compared to the output CT currents. Failure to wire these inputs correctly will cause maloperation of the differential element. In addition to the differential protection, the neutral NCTs are also used for the distance element and offline overcurrent protection. If the neutral NCTs have not been wired to the relay, these protection elements will not be available. The 489 has a dual primary isolating transformer for ground CT connection. There are no internal ground connections on the ground current inputs. The 1 amp 5 amp tap is used for either zero-sequence core balance applications or residual ground connections. The maximum ground CT primary current is 10,000 amps for the 1 amp 5 amp tap. Alternatively, the 50 to 0.025 ground CT input has been designed for sensitive ground current detection on high-resistance grounded systems using the 50 to 0.025 core balanced CT. The exact placement of a zero-sequence CT so that only ground fault current will be detected is shown here. If the core balanced CT is placed over shielded cable, capacitive coupling of phase current into the cable shield may be detected as ground current unless the shield wire is also passed through the CT window. Twisted pair cabling on the zero-sequence CT is recommended. The SR489 offers a total of 4 voltage transformer, or VT, inputs. The 3 phase voltage inputs are dedicated for generator terminal voltage, while the 4th is used for metering the generator neutral voltage. The phase VTs are used for measuring the voltage in the system. Power calculations, voltage protection, and frequency protection are all based on these metered values. The neutral VT connection is used for the neutral overvoltage and third harmonic undervoltage protection elements that provide the 100% stator ground protection. There are 2 different wiring configurations for the phase VTs. A Y connection requires 3 VTs, 1 for each phase. This connection will provide line-to-neutral voltage measurements. An open delta configuration only requires 2 VTs and will provide phase-to-phase voltage metering. Line-to-neutral voltage cannot be measured and will not be displayed. As the internal VTs of the relay are arranged in a Y configuration, the B-phase and VCOM terminals must both be shorted to ground if an open delta configuration is to be used. Regardless of the wiring configuration for the phase VTs, there is a maximum VT ratio of 300 to 1 allowed, and the nominal secondary voltage must fall between 70 and 135 volts to allow proper metering and to protect the relay from damage due to high voltages. Failsafe. At this time, it is appropriate to review the terms failsafe and non-failsafe. GE Multilin defines a failsafe relay as a relay that is normally energized and will de-energize when called upon to operate. It will also de-energize when the control power to the relay is lost. Within the relay, there is only one relay assigned as failsafe. This is the R6 service relay. It has a Form C contact output configuration and will de-energize if there is an internal failure of the relay. The other 5 relays are non-failsafe, and so they will normally be de-energized and will energize when called upon to operate. Shorting bars in the drawout case ensure that no trip or alarm occurs when the relay is drawn. Only the service relay will de-energize, indicating that the relay has been drawn out. The trip relay, R1, is intended to be used as the main trip relay. It should be wired such that the generator is taken offline when conditions warrant. Supervision of a breaker trip coil. The SR489 is able to supervise the breaker trip circuit. All that is required is that the supervision circuit be paralleled with the R1 trip relay output contacts as shown. If connected as shown, the supervision input circuits will place an impedance across the trip relay contacts that will draw a current of 2 milliamps for an external supply voltage from 30 to 250 VDC through the breaker trip coil. The supervision circuit responds to a loss of this trickle current as a failure condition. Circuit breakers equipped with standard control circuits have a breaker auxiliary contact permitting the trip coil to be energized only when the breaker is closed. When these contacts are detected to be open by the breaker status digital input, the trip coil supervision circuit is automatically disabled. This logic ensures that the trip circuit is monitored only when the breaker is closed. If trip coil supervision is enabled and 52 open-close option is selected for the breaker status input, The trip coil supervision circuitry will monitor the trip coil circuit for continuity at all times, regardless of breaker state. This requires the installation of a resistor as shown to create an alternate path around the 52A contacts in series with the trip coil when the breaker is open. The chart shown gives suggested values for the resistors depending on the control voltage used. Auxiliary relays R2, R3, and R4 are intended to be used for special control functions, such as sending an upstream remote trip command to a breaker on an IOC fault. It is a good idea to decide early on what function each of these relays will perform to avoid assigning conflicting functions to the same output. To ensure conflicts in relay assignment do not occur, several precautions have been taken. All trips default to R1 trip output relay, and all alarms default to the R5 alarm relay. The alarm relay is intended to be used as the main alarm relay and should be connected to the appropriate annunciator or monitoring device. The Failsafe service relay R6 will operate, in other words, de-energize, if the relay detects an internal fault or control power to the relay has been removed. This output may be monitored with an annunciator, PLC or DCS. Another application is to wire the R6 service normally closed contact in parallel with the trip relay. This will cause the generator to trip offline if control power is lost to the relay or if the relay detects an internal fault. This will provide fail-safe operation of the generator. The relay is equipped with 3 independent communications ports. The front RS-232 port is designed for direct connection to a PC. There are also 2 communications ports located on the rear terminals of the relay called the computer and auxiliary communication ports. All 3 ports are configured to communicate using Modbus communications. However, one of the 3 ports can be programmed for DNP communications. The front RS-232 port requires a straight-through RS-232 cable to connect it to a PC. It is intended for accessing settings, event recorder, and oscillography files, as well as upgrading firmware to the relay. The baud rate of this port is always 9600 bits per second. The rear communication ports are independent RS-485 ports. Both ports can be accessed at the same time and are intended to be connected to a Modbus or DNP communication network. A maximum of 32 devices can be connected to a single daisy chain. Baud rates and parity can be set independently for each port. To reduce communication errors caused by noise, shielded twisted pair cable is recommended. The cable should be grounded at only one end, either at the relay or the master device. Terminating resistors and capacitors are also recommended to reduce interference. The SR489 relay is equipped with 12 RTD inputs. These inputs can be programmed as stator, bearing, or ambient, and are user programmable for 100 ohm platinum, 100 ohm nickel, 120 ohm nickel, or 10 ohm copper RTDs. The 489 is designed to properly meter RTD temperature using a 3-wire method. These leads are designated as the hot, compensate, and return leads, and each have their own dedicated inputs to the relay. The relay RTD circuitry will compensate for the resistance of the RTD leads, provided that all 3 leads are identical in length and have been wired correctly. It is important to note that the RTD circuitry is isolated as a group with the analog input and output circuitry. Only a single ground should be used for all 3 circuits. Rigby is a standard timecode format that allows the synchronization of time between connected relays. To ensure accurate and synchronized time stamping of events, the SR489 relay can be connected to an Rigby network using coax cable. This will ensure that the real-time clock of the 489 is accurate within 1 millisecond of all other relays connected to the Rigby generator. The number of relays that can be connected to the generator will be dependent on the generator's load rating. The 489 relay is user programmable for both amplitude modulated and DC shift Rigby signals.